Okay, now we will be looking at graphing second degree functions, quadratic functions. And first off, let's identify our a, b, and c values, which are basically the coefficients of my second degree variable, coefficient of my first degree variable, and my constant. So for in this case, the coefficient of my second degree variable is 1, is basically the value, the coefficient right here. So there's 1x squared. So a would be 1. My here I have negative 5x, so negative 5 is the coefficient of my first degree variable, and 6 would be my constant, which is the number by itself. These values will come into play later on, but for now we won't be using them. Now let's take a look at substituting an x value to generate a y value into my function. So let's do that. Let's start off with maybe 0. 0 is one that's quite easily calculated. If x squared 0 and then negative 5 times 0 is 0. So 0 minus 0 is 0. 0 plus 6 is 6. Let's continue with the positive numbers. So 1 squared is 1. Negative 5 times 1 is negative 5. And then plus 6. So 1 minus 5 is negative 4. Negative 4 plus 6 is 2. And then let's continue along that line of thought with 2. 2 squared is 4. Negative 5 times 2 is negative 10. Negative 10 plus 6 gives me 0. Interesting. And then let's take a look at 3 squared, which is 9. Now, if negative 5 times 3 is negative 15 plus 6, also 0. And then here, I got 4, so let's do 4. So 4 times 4, which is 4 squared, is 16. 4 times negative 5 is negative 20. So that's negative 4 plus 6, which gives me 2. And then finally, let's take a look at 5 squared, which is 25. Negative 5 times negative 5 is 25 negative, and plus 6, which gives me 6. So usually students don't have any difficulty calculating for positive values. It's when it's negative values. So be very careful when substituting a negative number. The big mistake that I see over and over again is they'll do this. Negative 1 squared is negative 1. That would be a mistake. It's actually use your brackets when substituting, especially for a negative number. Negative 1 squared is, in fact, negative 1 times negative 1, which would give me 1. Be very careful. Same idea here. Negative 5 times negative 1, because when you're substituting, remember, you're multiplying by the coefficient of the variable. So negative 5 times negative 1 is plus 5, and then plus 6. So that would give me 6 plus 6, 12. So be very careful. Now I have all my table filled out. I will take this information and then graph it and see what type of representation I'm going to get. So let's start off here, negative 1, 12. So negative 1, 12 would give a point value around here. 0, 6 would be around here. And then 1, 2, 2, 0, 3, 0, 4, 2, and then 5, 6. So what you notice here is you'll have kind of like a bell-shaped curve. If I were to ask you to calculate y if x would be 6, you quickly maybe realize that there's a pattern showing up here and there are symmetrical points. So you probably say it was 12 without calculating, and sure enough it is. So you'll always end up with this shape if you do it correctly. It's called a parabola. And we will be talking about this in our next video. The correct characteristics of this parabola.